Hi, good morning. Welcome to the today's session of computer organization and architecture. Next topic is interrupt nesting. So now if you consider interrupts, we have already discussed so why it is important to have a mechanism of enabling or disabling interrupts. So if you consider a single line for accepting the interrupt request from all the devices. So in such case, or if you consider one device has raised the request, so if that device interrupt is being serviced, then we should disable that interrupt so that there should not be any multiple requests from the same device. So if there is such condition, that is if the same device is raising multiple requests, then as we have discussed, it may enter into an infinite loop. And also when we have multiple devices connected over a single interrupt request line, then also it is essential to have such mechanism of enabling or disabling interrupts. And so since the interrupt service routine is very small, then if we make one device to wait for some time, then it is not a problem. The delay is very small, that can be neglected in some of the cases. But if we consider some applications wherein that delay is crucial, then so we need to consider to have some mechanism to organize these interrupts. So if you consider an example, it is better to consider an example in order to understand wherein we will be having such a problem. So if we consider a computer, so that is keeping track of the time of the day using a real-time clock, let us assume such applications will be sending the interrupt request continuously. Why? Because since it has to keep track of the time, so if at regular intervals it will be sending interrupt request to update the counters of seconds, minutes or hours, etc. So in that case, what happens is it is going to continuously send the interrupt request at regular interval of time. So in that case, so if you consider the interrupt request, so it has to be serviced as soon as possible, because since it has to increment the counters, like seconds counter, minutes counter or hour counter to keep track of the time. So and the request will be coming in a regular intervals, so it is essential to service as soon as it arrives. But if you consider there is a delay, then in order to have a proper operation, it is essential to see that the delay between the two requests, the delay in executing the ISR is small, such that it is less, such that the difference between the two requests, so the time difference between the two requests what we have, so the delay must be less than that difference. Therefore, so in that case it is essential to have mechanism wherein we will be having a priority, so wherein we will be having an organization, so where we are going to provide priority to certain interrupts so compared to the others, because in such applications it is essential to consider the request from the application rather than considering the request from other devices, because it may end up in some erroneous operation. Because of that reason, so it is essential to organize the interrupts in such a way that there is some priority to the processor. And if you consider the priority to the processor, so it is set by the programmer, and we will be having an instructions called as privilege instructions, so using which we can set the priority to the processor, and that priority can be set only when the computer is operating in supervision mode. So whenever it is operating in supervisor mode, then we can set this priority using the program control, and that can be done only when the computer is operating or is executing some OS programs. So it is not possible to edit, or it is not possible to change the priority in user mode. So whenever it is in supervision mode, we can use the program control, you can use or we can edit or we can change the priority which is assigned, but it is not possible for an user by intentionally or accidentally change the priority given to or assigned to the processor. So if priority is assigned, then how it is going to work. So if a priority is assigned, then the processor is going to accept the input, okay, accept the interrupt request, so of the devices which are having higher priority than the currently being executed ISR. So if the interrupt service routine which is being executed so is having highest priority, then all other interrupt requests will not be considered, all other interrupt requests will be neglected, and the currently being executed interrupt service routine will be executed. But if you consider there is an interrupt request from a device which is having higher priority than the presently being executed so interrupt request, so then it is going to consider that aborting the execution of this, that is halting instead of saying aborting. So it is going to halt the execution of the presently being executing ISR, and it is going to consider an interrupt service routine, or it is going to consider an interrupt request which is having highest priority than the currently being executed service routine. So after execution of that, so it is going to come back, it is going to resume, and it is going to execute the ISR of the previously executing program. Let us see so the diagram, so how this will be organized in a computer. So we will be having a processor, and there will be a circuitry which is called as priority arbitrary circuit. So priority arbitrary circuit, and let us consider there are P devices, device 1, device 2, etc., device P. Let us consider we have, so let us so call this as INTR1, so this is INTR2, INTR bar. We have discussed the hardware circuitry previously, so this is INTRP, since it is a request from the P device, so this is INTR bar P, and you will be having an acknowledgement INTA1, INTA2, and acknowledgement signal to the second device, and INTA, INTA P. And here if you observe, so we have P devices, so which are having separate interrupt request line, and we are having separate interrupt acknowledgement line, and all these are connected to the processor, and I have written priority arbitrary circuit. So this is a circuit which is going to combine all the interrupt requests, and is going to select an interrupt which is having highest priority. That is the function of priority arbitrary circuit. And here, so in this, so we have all the devices which are having separate interrupt request line. So the advantage of this scheme is, so any device can raise the interrupt at any point of time, and so it is going to select an interrupt request, so which is having highest priority, and the processor priority is going to be the priority of the selected interrupt request. So if it is there is a request from a device which is having highest priority, then the processor priority is going to change from the lowest to the highest. And so that is how the operation occurs if you consider the priority the priority or interrupt nesting using the priority structure. So this is the diagram of the interrupts with priority. So this is the diagram of interrupts by considering So if you observe, we have separate acknowledgement lines also from the processor. So but in this case, so we will be having a wiring, okay, which is a very complex wiring, because all the devices are connected or having individual interrupt request line and also separate acknowledgement line. So because of that, so circuitry will be complex. But so if you consider the service, okay, so that is where whichever is having the highest priority, so that will be the one which is, okay, serviced first. Okay, the instructions, okay, that are used to change or the set the priority of the processor are called as privileged instructions, and these can be used in case of the processor whenever it is in supervision mode, okay. And if you try to, okay, if the user try to change the priority or edit the priority which is assigned, okay, whenever the processor is in, okay, user mode, in that case, so we call that exception as privilege exception. So these are the, okay, points we need to remember, so in interrupt nesting. Next is simultaneous request. Now let us, okay, understand how the simultaneous requests are considered in a processor. So if you consider there are, okay, multiple devices connected, then since the devices are operationally independent, then we know that so any device can raise request at any point of time. Therefore we may encounter the situation wherein we will be having simultaneous request. So in that case, as we have discussed just now, that is the priority, okay. So interrupts with the priority, in that case it is very easy, it is very straightforward. It is going to select, okay, an interrupt request from a device which is having highest priority. So in that case, so since we have separate INTR, that is interrupt request, okay, lines, so then using that method it is easy for us to, okay, overcome the problem what we have with the simultaneous request. But if you consider, okay, a computer or a processor which is using a single interrupt request line, so in that case, so how to, okay, overcome the problem of simultaneous request. So that is very important. So in that case, so if you use the polling technique, so it is the very simplest technique, okay, which can be used in order to detect, okay, which device, okay, it has raised the request. But so polling technique, as we know, so it is going to, okay, poll all the input output devices, and so whichever is encountered with the, that is IRQ bit, whichever device is encountered with its IRQ bit set, so then it is going to identify that, and it is going to, okay, that the processor is going to service or it is going to execute the interrupt service routine. Yes, so now the simplest mechanism which is used to, okay, handle this simultaneous request is called as daisy chain. Using daisy chain connection, okay, so it is one of the wiring type in a computer system. So daisy chain is nothing but a wiring mechanism, so wherein the devices will be connected in a sequence like a garland. So it will be connected in a sequence, and so it is going to continuously the interrupt acknowledgement signal is going to, okay, continuously propagate from one device to the other device. So depending on the request raised, okay, depending on the connection, actually instead of saying request raised, so depending on the, okay, connection which is made, so the processor is going to detect the interrupt request and is going to service the device, okay, which is closest to the processor in connection. So let us, okay, understand it by drawing the diagram of a daisy chain connection. So if you consider the processor, okay, yes, so we have device 1, device 2, etc., device N, and all these are connected to a single interrupt request line. So INTR bar will be a common, okay, line for this, and you will be having INTA, so which is propagated from one device to the other device. So now in this case, so how the interrupt request will be serviced is, so whenever there is a request from any one of the devices which is connected to the INTR, okay, so it is going to send a signal to the processor saying that there is an interrupt request. So as soon as it recognizes there is an interrupt request, it is going to set the INTA signal, okay, to 1, and that INTA signal will be given to the IO devices, and INTA signal will be passed to, initially it is given to the device 1, and device 1, if it has raised the request, then it is going to block that INTA from propagating it to the next, okay, device, and it is going to give its special code, okay, because so all the devices are connected, so it is essential to identify which device has raised the request. Therefore, it is going to give a special code to the processor, and the interrupt service routine of that particular device will be serviced, okay. But if it is not having any request, in that case what it is going to do is, it is going to pass that INTA signal to the next device, okay. So this is how the daisy chain connection works. So this is how the problem of simultaneous request will be overcome, okay, using a daisy chain connection. So here, so if you observe, the device which is connected or which is closest to the processor will be the one which is serviced first, okay. So the device which is electrically closest, okay, electrically closest to the processor will be serviced first. And in this case, if you consider the wiring, so we have less number of wires required to make, okay, such a connection. And so now here the priority is not included. If you want to include, okay, both the techniques, that is, so if you want the advantage of having separate interrupt request line, because if you have separate interrupt request line, there we can have, okay, the priority, and if you have this daisy chain connection, we can solve the problem of simultaneous request. So combining these two, okay, we can have another diagram wherein we will be having group of devices with different priority levels. So you can group the IO devices in such a way that, so the priority, okay, is given to the devices, so which actually, okay, require the attention of the processor at the earliest. So by giving the priority also, you can have the daisy chain connection. So let us see the diagram. So combining the previous one and this one, so we will be having, okay, processor. Inside that we will be having arbitrary circuit, so processor, okay, then priority arbitrary circuit, priority arbitrary circuit, okay, and so individual, okay, so device groups will be there with different priorities, etc. And all these are connected over a common INTR, okay. And here, so for this group you will be having, so INTR 1, and for the next group, so you will be having INTA 1, because this is an acknowledgement signal to this group, okay, and you will be having device, okay, 1, device 2 of this particular group, etc. Okay, so this is INTA 2, this is INTR 2, okay. So like this, so we will be having n groups. So for the last group it will be INTRN, okay, INTR bar n. So yes, so you will be having device, okay, so device, yes, etc. Okay, so group of devices connected like this. So if you observe, so we have INTA, so which is being propagated, okay, through the group of devices, and each group will be having separate or different priority levels. Okay, so this is the arrangement which is used in most of the computer system. We will be having the combination of the priority, interrupt with the priority and the daisy chain. Okay, so internally if you observe, so this INTA signal is being passed from one device to the other device. So these devices are connected in daisy chain fashion, and group, if you consider, each of the group is having priority levels, separate priority levels. So this is about the simultaneous request. So in today's class we have discussed about the interrupts, handling the multiple interrupts, and we have seen so what are all the mechanisms we have, and we saw how the simultaneous request will be handled in a computer system. And in next class, so we will be discussing how to control the multiple interrupts, and then we will be discussing the last IO techniques, that is direct memory access. Yes, so thank you for watching. We will be continuing in the next class. Thank you.